Well, greetings once again. Welcome to Trigonometry for students and surveyors. This is lesson 5. And now we're going to start doing some fun stuff. And let me get my calculator here. All right. First one we're going to do over here, we've got our triangles. Should I put those on? Nah, I don't need those. So we have our triangles kind of figured out. We worked those, like I said before, pretty much every which way. So hopefully you got those all down. So now we're going to use a practical application of it. So we're going to pretend that somebody wants to fall a tree. They want to get a tree out of there. They want to know how high the tree is. And they happen to know that there's a surveyor around or somebody that knows trigonometry. They want to figure out how high that tree is. Because if it's too high, because there's a house over here, which I haven't drawn in. Actually, I did. A really nice detailed house, but there's a blizzard right now, so you can't really see it. But it's right there. Okay. Or maybe it's down there. So there's a house there. So he doesn't want to fall the tree on the house. And he doesn't necessarily want to hire a tree climber because they cost a lot of money. Thousands of dollars. So if he knew how high the tree was, he'd be safe enough to fall it. So that's where we come in. So here's our tree. And what we've done, so now I want you to think about the triangles and how we actually use those now. How do we use a triangle? How can we solve that tree? So let's look at it. I got some numbers here. Ignore these. Now this is for something else that we're going to do later. So what we need to do is you can't measure this. Now actually, the survey instruments we have now, you could set it up anywhere and measure anywhere you want. And shoot prismless or shoot a prism. You can shoot a prism down here, shoot prismless if you wanted to. And it'll tell you how high the tree is. When I said data collectors do everything, that's exactly what they do. They do everything. Pretty much easy. They can shoot prismless without a prism. The way a survey instrument works, it shoots a beam of light out, and the beam of light comes back, and it times it. It calculates what that is, and that gives it the distance. So here's our tree. Now we got part of the thing of surveying obviously is problem solving. And you got to look at the problem and say, well, how do we solve that? What do I have? What part of a triangle here? Sine, cosine, tangent. What can we use on this? Well, we can't measure the hypotenuse because there's no way to measure that. Same with the cosine. We don't really have that, but what we can do is we can get a horizontal distance. We can run a rag tape is like a tape rule I showed you, but they're bigger, 100 foot, 200 foot. We can walk out with a rag tape and stretch it out and find a place suitable. Now this is my instrument. This is this guy over here. This is set up on a tripod. It doesn't exactly look like it, but I'm not an artist. So that we just sat there, we just said, okay, I can see this now. I can see the tree. So we turn it 90 degrees and we're going to pull a tape from the center there to there because we're going to pretend that we can't measure with our tripod or with our transit. We just want to be able to see it. So in a 90-degree angle, we're shooting the tree about there. So we need to figure out the distance from here to here. Now what we know is it's 98 feet to there. Now we're going to have to add this distance down here, or else we're going to have to trig that distance down there. So we can also measure that, and then have climb up on a ladder and measure from that point on. We have to make a mark. But we need a horizontal distance. So our horizontal distance is 98 feet. We've sat there and now we've turned up our angle to the top of the tree. This is a vertical angle, not a zenith angle. We're going to get into that later. That's going to be fun. So that's a vertical angle of 53 degrees. We're just going to do even degrees for this experiment. So this dashed line represents the horizontal distance. 53 degrees is from this dashed line. Now we've got another one over here. We'll get to that in a minute. So we have, what do we have? We have a right triangle. And then we have 53 degrees and we have the horizontal distance. So what do we need there? We don't have this distance. So we do, but we don't. That's coming in later. We have the 98 feet and we're looking for that. So remember, Tangent is the opposite over the adjacent. So we're looking for the opposite. This is the opposite. We have the adjacent. All right. So since we don't have the distance to get the angle, but we do have the angle so we can get the distance. So we're going to put in 53. 53 store, I'm just going to go store 5. I'm going to write that in there too. I like to write them in because I got a whole bunch of other stuff stored. Oops. So that's where I've stored 53. Now you can store yours anywhere you want. So there it is, 50 feet, 3 degrees. Now we want the tangent. So again, what we talked about in the last lesson, if it's over 53 degrees, or if it's over 45 degrees, then this opposite is going to be longer than this side. Side A, we'll call that, so let's just go ahead and label them out. Call this side A, or angle A, and side, oops, it's lowercase. All right, that's that distance. So we have, what we're doing here, 53 degrees, and we want the tangent of that. So 53, okay, 53 degrees means that one's going to be longer. So we're going to go tangent 13270, and now we're going to go the times 98, and that is 130.05. I've written it down here. Now I'm rounding it off. Of course, we're following a tree. It's fine to round it off. We're going to round it off. So 130. So that's how high it is from there to there. Okay. So now what about down here? So why don't we go ahead and trig the lower part too? Okay. So we have 8 degrees is what we have there. 8 tangent, and the same horizontal distance. 98 times 1377. I just rounded it up to 14, add them together, rounded it to 144. So that's how high that tree is, 144 feet. Now the guy knows he can pull the rag tape out towards his house, towards his barn, towards whatever he's afraid that thing might hit, and he'll know where it's going to hit. He'll know how long it is. So you've done a service through trigonometry. That's a practical use of trigonometry. So just to be sure, just so there's no confusion, so this was also a right triangle. So this is horizontal and a right triangle, and this is the hypotenuse down here. When we're doing slope distances and stuff, you're going to have the hypotenuse is down, hypotenuse is up for vertical. Okay, so if you added, what about if you added 50, you could get the whole, so we added those together. We added 130 up, 14 down to get 144. Why don't we just add 53 and 8 together? Well, because it doesn't work. If you add 53 and 8 together and use tangent, you end up with 177. That's not the right answer. So there's another way to check it. So I wanted to check my work. So what I'm seeing there is a non-right triangle. And now I want to calculate that. So what do I have? I have these two angles together make 61 degrees. So 61 degrees with this, let's see, what are we talking about here? Oh yeah, I used 53 degrees and 98 feet to get the cosine. That's where I come up with 162.84. Okay, so not 61 degrees. I used 53 degrees, the cosine 98 feet, inversed it, got 162.84 for the hypotenuse. Did the same thing with 8 degrees, the cosine 98 feet, inversed it and got 98.9631. So then what I did, I stored 61 at my favorite place for the angles is 0 for theta. 61 is stored. This is where, okay, this is where the HP35 and these types of RPN calculators really show their stuff. I got to say, I haven't even tried it on the 42S. I'm going to probably be trying that this evening after we're done, but I'll try it on the 42S, see if I can run this equation that we're going to do over here. So what we're going to do is called the Law of Cosines. Law of cosine. It's quite a long calculation here. So I've stored 61 in 0. I've stored side A in 7, my 7 key. And I've stored side B in my 3 key. No particular reason, it's kind of a memory thing for me. On the calculator you have 0, 7, and 3. If you really look at it, it looks like this, 0, 7, 3. This is the angle. So you actually have, it's just an easy memory thing for this. No other way. You can also store it anywhere you want. You can store side A under A, the alpha A, side B under the alpha B. Anything you wanted. Okay. So how do you do? We're gonna calculate this using, this is now a non-right triangle. Now we're not going to get into non-right triangles yet. Just going to show you. I had to check my work, so I decided to go ahead and write out the formula. And I'm not going to walk you through every step of it. Just give you an idea how this works and what we're going to be coming up to when we start doing non-right triangles. So the law for that, that's law of cosines, is a squared plus b squared minus 2 times a times b times the cosine, and then you take the square root of that. Now I'm going to walk you through that now. I believe I've done this on an app. You can switch this to algebraic mode. 2 divided by 2 instead of 2, enter 2 divide. You can put it in that way. I think I have got it to work out, or maybe it was my 33. I can't remember, but it seems to work out really well in the RPN mode. So you can try this formula in your calculator, but this has a stack of 4 registers up here, 4 stacks, and they can take these rather than having to put your multiplication in parentheses. It sort of does it for you. So let's just work through this. Now this is another reason why I like to store it. You don't have to re-enter everything in every time, and also when you store, it's carrying out the decimals for you, so it gets a little more accurate that way. So a squared plus b squared minus 2 times a times b times the cosine. Okay, so we're going to start over again. Recall 7, 162 squared. Recall squared. What was that one? A squared plus b squared. Okay, plus. It's because I'm talking. Let me just start over again. Recall 7 squared. Recall 3 squared plus 2, enter, recall 7 times, recall 3 times, recall 0, cosine, times, and then minus. Okay, 20,658, and now we want the square root of that. Is 143.8234. 143.8234. I rounded off 144, just like I did that one. I just made one little mistake. When I hit 2, minus 2, I think I didn't hit enter. So it just didn't go so that's where that comes in. So that's why these calculators are very nice to do a long equation like that. So that's 143. Now we had 130 feet up, we had 14 down, 144, 143, 82 is 144. So there you go. You've trigged out the height of that tree, checked it with law of cosines. That all checks out. Okay, where are we at now? Okay, so there was a high water. There's a village over here, or there's some people over here at Island. They can't get off, the water coming up, they're going to be in trouble. We've got to get the fire department come to you and say, hey, you're a surveyor, I need to know what the distance is here. We're going to order in a military bridge. We used to call them Bailey bridges. And we're going to bring it in. If the bridge is gone, we're going to drop it on these 2 abutments, these 2 bridge abutments. We need to know what the distance is because we don't know what the distance is. And they got to be built just to fit, okay? Now, again, today's instruments, you can just set it up shoot these two things, give them the answer. You don't even have to crawl. You could, but that's cheating. That's just cheating. All right, so what we want to do is, how are you going to do that? How are you going to measure that? We have nothing to go, we really have nothing to go on right now. So I'm going to give you guys just a second before I start yakking here. How would you do that? We need to make, we're not dealing with laws of cosines, we're going back to right triangles again. How do we do that? Okay, so what we got to do to measure that, we got to sit the gun here, and then we want to sight that. We want to sight there what we're going to aim at. Let's just say there's a bolt here. There's something sticking up. This will give us nice and precise sighting. There's a bolt right in the middle of it. There's bolts here to bolt it down. There's bolts here. But we're going to sit our instrument right there. We're going to sit right there. We're going to back sight that. That's called a back sight. We're going to sit right there. We're going to back sight that. And then we're going to turn it 90 degrees. We're going to just, well, our gun's telling us we're turning at 90 degrees. And that's what we're going to do. And I believe I put a little dot here. So this, let's put an imaginary one here now on these two bolts. All right, let it go. Put magnets on there. Okay, so we have a 90 degree here. Now, we don't have this distance. We don't have this, but we've turned a 90 degree. Now we can measure this distance. So when we survey, we call that setting our backside at 0. We're going to zero out on that. Now we're measuring 90 degrees. Now we measure down here. We're going to call this, we're going to say we've set our tripod, another tripod here, a foresight up here, and that's 223 feet. That's 223 feet here. All right, well, we're starting to build a triangle. That's terrible writing. 2, 2, 3.0. All right. So we got something now. We got one side. That's all we got. We got a 90. We know that. So now we're going to pick up the gun. We're going to set our backside there. We're going to set the gun there. Now we're going to backside this one, and we're going to turn that angle there. Let's just go and put my little doodad in here. Okay, so there's the center bolt. All right. Now, remember, a right triangle, you need two sides or one side and one angle to solve it. So now we're sitting here, we're backsighting there, we got a 0 on. Now we're going to turn this angle. So what's this angle? Well, I already wrote it in here. It's 34 degrees. So we've got 34. Now remember, we don't have to convert if we're just using straight degrees. And there we are. So what are we looking for there? We're not looking, same with the tree, we're not looking for the slope distance to the top of the tree. We don't really care what the hypotenuse is, although we can solve that. What we're looking for is this distance here, and that would be, this is angle A again, good old angle A, and side A. We're looking for side A. Then we can get the guy on the road and go get on the radio and get a new bridge flown in with a whirly-bird helicopter. Okay, so let's do that. Give you guys a second to figure out how to do that. I think you should know by now. That's a tangent function. Opposite over the hypotenuse. Or opposite over the adjacent. Sorry, that's the adjacent. This is the hypotenuse. We don't have the distance for the opposite, but we already have the angle. You have the distances, you can get the angle. If you have the angle, you can get the distance as long as you have one side. What we couldn't do, we could also get the cosine from here. because we have the angle and we have the adjacent. So we could also get the cosine because they connect here. What we can't get from here is the sine, because we don't have either one of these. You couldn't use the sine because you would need one or the other of these and use that to get the sine. All right, but we can once we solve this out. So we're going to go 34 degrees, 34, enter that, and we're going to go tangent. Now remember, 34 is less than 45. That means the opposite's going to be less. And of course it looks like less. It's like a 3, 4, 5 triangle. It looks like it's less. So 34 degrees means that the opposite is going to be, it's less than 45, so it means the opposite is going to be less than the adjacent. So we're going to go 34, we're going to go tangent. So 0.6745. So that looks good. If I 1x that, if I inverse that, it would be 1.48. Well, that wouldn't be 1.48 longer, 1.5 times longer than that. So we'll just 1x it back. So now that is 0.6745. And we're going to hit enter, and 2, 2, 3 times. Our answer is 154,154. So we're going to tell him it's 150 feet. This is 150 feet from bolt to bolt. You've told him that. Now we could also elevations, you know, you could figure out elevation differences too and tell him what the differences on the elevations are. Same way, trig this way, they're triangles. And that's all there is to that. And we'll do some more practical stuff the next time we look for lesson 6. This is lesson 5. We'll do some more practical stuff, and pardon my drawing, I'm not an artist. So yeah. That's how you can use trigonometry every day. You know, when we haven't got into construction, roads, all that stuff. We've only mentioned that earlier, but that's how you do that. So we've got a tree, we've got a bridge. We'll save that guy from smashing his house. Help the guys, the rescue crew, get a bridge in there. You got the guys out. If you're a surveyor, they're going to say, "Hey, figure this stuff out for me." Okay, I know how to do it now. Law of Cosine, that's shows you what the power of the calculator is. There's others I've seen on websites that they do some very, very complex, way more complex than that. Just typing it all in there and it comes out. So, for 42S, I will try that, and I'll try to get back, if I can remember, get back tomorrow and see if I can do the same thing on that free download one. And that's all. Have a great day. Bye-bye.